The internet feels like magic. You type funny cat wearing sunglasses into your phone, and less than a second later, a cat from somewhere on the other side of the planet appears on your screen. But the internet isn't magic. It's basically billions of computers sending tiny packages to each other, while a bunch of machines desperately try not to send them to the wrong place. Let's say you want to visit YouTube. You type youtube.com into your browser. But your computer has a small problem. It has absolutely no idea where YouTube is. Computers don't really understand names like youtube.com. They use IP addresses, numbers that identify devices and servers on a network. You can think of an IP address like a home address. If I tell a delivery driver, please deliver this package to Alex, that's not very helpful. Which Alex? Where does Alex live? Is Alex even real? So your computer asks something called a DNS server. Hey, do you know where youtube.com lives? DNS stands for Domain Name System. It's basically the internet's contact list. The DNS server checks its records and responds with YouTube's IP address. Now your computer knows where to send the request. But the request doesn't just teleport directly to YouTube. First, it travels through your home network. Your device sends the data to your router, the box in your house that everyone blames when the internet stops working. Your router then sends it to your internet service provider. From there, the request travels through several other routers and networks until it finally reaches one of YouTube's servers. And yes, your data can physically travel through cables under the ground, and even huge submarine cables at the bottom of the ocean. So when people say that their data is in the cloud, that sounds very futuristic. But the cloud is mostly just somebody else's computer sitting inside a massive building. Once YouTube's server receives your request, it sends the website back to you. But websites, videos, and images are usually too large to send as one giant block. So the information is broken into small pieces called packets.
Imagine ordering a table online, but instead of receiving the entire table, you receive one leg on Monday, 2 screws on Tuesday, and half of the tabletop on Wednesday. Except internet packets arrive in milliseconds, and your computer actually knows how to put them back together. Each packet contains part of the data, as well as information about where it came from and where it needs to go. The interesting part is that these packets don't always take the same route. One packet might travel through one group of routers, while another takes a completely different path. Routers constantly look for efficient routes across the network. It's like Google Maps, but instead of avoiding traffic jams, it's routing your extremely important cat video. When all the packets arrive, your computer puts them back into the correct order. If one of them is missing, your computer can request it again. That's one reason why a bad internet connection can make a video freeze. Some of the packets may be arriving late, getting lost, or needing to be sent again. But how does your browser know what to do with all that information? That's where protocols come in. Protocols are basically rules that computers agree to follow. HTTP and HTTPS are used to transfer websites. TCP helps make sure packets arrive correctly and in the right order. IP helps send them to the correct destination. There are many more protocols, but you can think of them like different departments in a company. IP handles the address. TCP checks that everything arrived. HTTP carries the actual website. And HTTPS makes the communication harder for random strangers to read. The S stands for secure. Without HTTPS, someone on the same network could potentially see information you send to a website.
With HTTPS, the connection is encrypted. That means the information is transformed into something that should look like complete nonsense to anyone who isn't supposed to read it. So if you send the message, "My password is password123, an attacker hopefully sees unreadable encrypted data instead. Although if your password really is password123, encryption is not your biggest problem. And that is basically how the internet works. Your device finds the server using DNS, sends a request through multiple networks, receives the answer in tiny packets, and uses protocols to put everything together safely. All of that happens within seconds, or even milliseconds. The internet isn't one single machine. It's a gigantic network of networks, held together by cables, routers, servers, and a surprisingly large number of agreed-upon rules. So no, the internet isn't magic. It's just millions of computers politely asking each other, "Do you know where this packet is supposed to go?" And somehow, most of the time, it actually works, which is honestly more impressive than magic.